The term edge effect is used to describe the changes in a population that occur at the boundary of two or more habitats. These changes can include the abundance or occurrence of a species. Assuming an edge effect of 5 meters, we were able to calculate the amount of core habitat in our wild plot. Beginning with an estimated area of 25 hectares, we multiplied by 10,000 to convert the value to meters squared. We found the length of each side by using the square root of the area. We then multiplied by 4 to find the perimeter. After multiplying by the given edge effect value of 5 meters, we found that we have 10,000 meters square of core habitat in our plot. To analyze the invasive species in each plot for both birds and trees, we found the ratio of non-native to native species. The developed plot showed only one non-native species, being the house finch, giving us a 1:4 ratio. The wild plot showed 0 non-native birds, giving us a ratio of 0:3. We found 6 non-native plants in our developed plot and 17 native plants, giving us a ratio of 6:17. For the wild plot, there was only 1 non-native plant, giving us a ratio of 1:18. To find the metapopulation viability analysis, we selected a representative native species of bird and plant in our wild plot. We used the equation to solve for V, where N is the number of populations, which would be 12 for each pair of students' wild plots, S is the size of our population, K is the sensitivity to distance, D is the distance between populations in kilometers, and 600 is a constant value. For plants, we selected American burnweed, which is native to North America. There were 20 individuals in our population for which we designated a sensitivity constant of 0.4. Using the equation, we found that V equals 0.22. For the birds, we selected the cardinal, which had 5 individuals in the population. This species was given a sensitivity constant of 0.6, giving us a value of 0.05 for V. The difference between these values is likely a result of the variance in population sizes between the two species. Birds had far fewer individuals than American burnweed, so the metapopulation viability analysis for cardinals shows a lower value.
For our recovery plan, we chose the red-bellied woodpecker as our bird and the dogwood tree. Red-bellied woodpeckers live in a variety of habitats in the eastern half of the United States, including forests, wetlands, the suburbs, and forest edges and clearings. The minimum viable population size for birds is usually between 500 to 5,000. A conservative minimum viable population size for red-bellied woodpeckers would be around 2,000. This would still account for fluctuations. Dogwood trees are native to the northeastern and southeastern United States. They can be found in floodplains, slopes, bluffs, ravines, and gum swaths. They are most abundant in woodland soils with consistent temperatures and are sensitive to rapidly changing soil temperatures. The minimum viable population size for trees is usually between 500 to 1,000 individuals. For dogwood trees, a conservative minimum viable population size would be around 750. This number would still maintain genetic diversity. Red-bellied woodpeckers would require around 10 hectares per pair to allow for nesting and foraging. To sustain 2,000 individuals, about 1,000 hectares of habitat is required. For dogwood trees, they would need around 10 meters between mature individuals for optimal health. To sustain 750 trees, a minimum of 75 hectares would be required. The net benefit for red-bellied woodpeckers was over $23 million, and for dogwood trees, the net benefit was about $640,000.